I'm Dr. Raju Matthew. Now, I would like to introduce a new topic, namely quantum computing, pneumatics, and knowledge technology. This presentation or talk is based on my own research since 1982. I have been conducting research on informatics and knowledge since 1982. In 1984, I could formulate theory of knowledge consumption production correlation and stage theory of knowledge growth that got published in the Theoretical Problems of Informatics, published in 1985 under the editorialship of Professor A. Mikhailov, the father of informatics. My further research on algorithms for digital computers helped me realize the inability of digital computers to process knowledge and develop knowledge processing technology because they are very complex and a big data is required with a high speed. Classical computers or digital computers work in a binary manner to encode information in bits. More bits are added linearly, limiting the processing ability. The, the structure of data is linear and static, and algorithms of digital or classical computers are built upon linear and static data structure, limiting their speed and processing power. All complex problems are basically dynamic, nonlinear, and exponential. As such, classical computers are a total failure or ineffective to solve complex problems, especially knowledge processing. The structure of knowledge or the building blocks of knowledge, namely concepts, is dynamic, nonlinear, or exponential. That is why information technology based on classical digital computing is totally incompatible to process or handle knowledge but only data. It has been identified that with IT based or classical or digital computing, knowledge processing is practically impossible. Knowledge processing involves complex and advanced processing techniques far beyond the power and speed of digital computing. That is why we couldn't develop knowledge technology the way in which we develop data or information processing technology. On the other hand, quantum computing offers new possibilities of developing the complex and advanced knowledge processing technology with high speed and power. Knowmatics. There existed a lack of awareness on the nature, structure, consumption, production, delivery, and growth of knowledge, unlike data. A scientific or mathematical or cybernetic study of knowledge is essential for developing knowledge processing technology. To conduct such kinds of study of knowledge, pneumatics has been emerged. As early as 1985, Matthew formulated theory of knowledge consumption production correlation and stage theory of knowledge growth of individuals and societies by taking into account knowledge as a product having quantitative and qualitative aspects. These theories explain the explain knowledge as a product for consumption and production and growth. These two theories are the basis of Knowmatics, which in turn is the basis of knowledge processing technology and knowledge industry. Two knowledge theories and Knowmatics have been discussed in the well-referred scientific paper Knowmatics, a New Revolution in Higher Education, published in the Journal of the World Universities Forum, Volume 4, Number 1, 2011. Quantum computing. Quantum computing utilizes quantum mechanics to solve complex problems faster than classical computer by taking advantage of superposition and quantum interference of qubits. A qubit can exist in a multi-dimensional state. Qubits are represented by quantum particles. The manipulation of qubits by control device is at the core of quantum computer processing power. The quantum processor does all its work by processing qubits. Superposition states that we can add two or more quantum states and the result will be another valid quantum state. Every quantum state is a sum of two or more other distinct states. The superposition of qubits allow them to process millions of operations simultaneously. The power of quantum computers grows exponentially with more qubits. Quantum entanglements occurs when two systems link so closely that knowledge about one gives immediate knowledge about the other. Entanglement is the ability of qubits to correlate their state with other qubits. Classical computers work in a linear manner to enable information in bits. More bits are added linearly, limiting their ability and processing power. Certain computational problems could be tackled more efficiently with the quantum algorithms than with the classical computers. Quantum algorithms. Quantum computers rely on qubits to run and solve multi-dimensional quantum algorithms. As we know, an algorithm is a step-by-step procedure to perform a calculation or sequence of instructions to solve problems when each step can be performed on a quantum computer. The term quantum algorithm is applied for algorithms of which at least one of the steps is distinctly quantum using superposition or entanglement. Entanglement. One of the other counterintuitive phenomena in quantum physics is entanglement. A pair or groups of particles is entangled when the quantum state of each particle cannot be described independently of quantum state of the other particles. The quantum state of the system as a whole is in an indefinite state, although the parts of the system are not. When two qubits are entangled, there exists a special connection between them. Qubits can be entangled so as to make a quantum computer more powerful than a classical computer. With the information stored in superposition, some problems can be solved exponentially faster. Quantum interference, as qubits expose superposition, they can also naturally experience quantum interference, the probability of qubits collapsing one way or other. Because of the possibility of interference, quantum computers work to reduce it and ensure accurate results. Then, with this background, now we can think of developing knowledge processing technology. That is, the and this knowledge processing technology facilitates the development or growth of knowledge industries in a big way, to ensure knowledge intensification of entire human activities. Thank you.